Hello, geometry. And here we go with lesson 6. We've got 2 lessons left in unit 10. This is all dealing with angle measures and segment lengths. So the front page here is angle measures and the back page is going to be segment lengths. So up until now, we've had 2 types of angles show up in circles. We've had central angles and we've had inscribed angles. And central angles had their vertex on the center. Inscribed angles had their vertex on the circle. Well, what happens if it's not on either one of those? Well, this takes care of the other situations. So here's the theorem. The measure of an angle formed by 2 lines that intersect. Now, there's 2 parts to this theorem. It matters where they intersect. Okay, so if the 2 lines intersect inside a circle, then the measure of the angle, the measure of the angle formed by 2 lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. And I underline that. It's very hard to see that I underlined it, but I'm going to point it out. Arcs. There's 2 intercepted arcs. With inscribed angles, there was only 1. With central angles, there was only 1. All right. So with this, you've got 2 arcs that are intercepted. And in this picture here, hopefully you can see it, we're looking for the angle. So I'll call it, I don't know. Well, actually, it's already there. Angle 1. I'm looking for the angle. The 2 intercepted arcs from that are X and Y. Okay, so what we get here for the equation is measure of angle 1 is equal to 1/2 the 2 angles added up, so X plus Y. Okay, but what happens if the 2 lines intersect outside the circle? Well, that's where the second part of the theorem comes in. The measure of an angle formed by 2 lines that intersect outside a circle is half the difference, not sum, but difference of the measures of the intercepted arcs. Again, you're going to have 2 intercepted arcs. All right, so there's 3 examples here. Basically, the first one is 2 lines that go through the middle of the circle. Second one is a tangent line and a line that goes to the middle of the circle. And then the third one is 2 tangent lines. These are all talking about angles, though. So the measure of angle 1 is equal to half, and it's the outside angle minus the inside, or sorry, outside arc minus the inside arc. So it's going to be in each of these X minus Y. So angle 1's here. The outside arc is the one furthest away from the angle. So it's X in all of these. Okay. So that is the theorem with both of its situations. Now we're going to go down and do some practice. Find the measure of each indicated arc or angle. All right, so pretty basic number 1. First thing you want to look at, though, is where is the intersection? Outside, inside. And when we get to the test, it's going to be outside, inside, on the center, or on the circle. So this one is inside the circle, not on the center. So that would be 1/2 X plus Y. Well, let's figure out the intercepted arcs. Follow the lines to the circle. There's 1 intercepted arc. It's 90. Plus the other intercepted arc, follow the other way. Probably guess it's 46. 90 plus 46 is 136. And then divide that by 2, and you get X equals 68 degrees. Okay. Next one, where is the intersection? Pretty easy to see that it's outside. The angle is outside the circle. So what are the 2 intercepted arcs? I'm going to follow the line. The outside one is the one that's furthest away. That's 95. The inside one is unknown. That's what we're looking for. The inside one is Z. So 1/2, and it's always the outside one, 95, minus the inside one, which in this case is Z. Well, that doesn't help me. But remember, it's an equation. If you go back up to the top, you see it's the measure of angle 1 equals 1/2 X minus Y. Well, the measure of the angle, I know this time, so I'm going to put that in. 20 equals 1/2 95 minus z. If I went back to the first practice problem, I could have put an x equals in the front of it. But since all the variables were all the known numbers, sorry, were on the same side, I didn't have to really make an equation out of it. This one I do. I have to solve this. I'm going to get rid of the fraction by multiplying by 2. I get 40 equals 95 minus z. Subtract 95, I get negative 55 equals, and that's a negative z. Divide by negative 1, I get z equals 55. This last one here is quite a bit more challenging. I've got the angle is 50 and it's outside the circle. So I know I'm doing 50 equals 1/2 something minus something, right? Keep in mind it's minus. Now, what is the only other thing I was given? I was given that 100 degrees for WH. Well, that's not even one of my intercepted arcs. My intercepted arcs are TW and TH. Those are my two intercepted arcs. I don't have anything there. I'm going to put an X here, and I'm going to actually, no, to stay consistent. We'll do outside arc is X, inside arc is Y. Right? So what do I know about X and Y? Well, I know that X, Y, and 100 have to add up to 360. So that means if I subtract 100, I'm going to have X plus Y has to equal 360 minus 100, 260. Right? So subtract 100, I get 260. Okay, so what do I do with that? Well, let's change Y so that it has an X in it. Or let's change X so it has a Y in it. Doesn't really matter which way you go. I'm going to get the outside arc changed. So I'm going to change X to Y. So I'm going to get X by itself. So I'm going to subtract Y from both sides. I get X equals 260 minus Y. Okay. Now, I can take X out and replace it with that 260 minus Y. So my outside arc is 260 minus Y. And then I subtract, oops, sorry, that's not quite right. 260 minus Y minus the inside arc, which is also Y. So that actually simplifies a little bit more to 260 minus 2Y. The Y's don't cancel there. They combine to make negative 2Y. Now we've got a very similar situation to what we had in number 2. I'm going to multiply by 2. I get 100 equals 260 minus 2Y. Subtract 260, I get negative 160 equals negative 2Y. Divide by 2, I get 80 for Y. Now, make sure you look at it. Sorry, that's not the right answer. Y equals 80. But then it says find the measure of arc TH. So that would be this one. So I'm going to put 80 back in. So 260 minus 80. I believe that gives me 180. Gives me 180. Yep. So 180 degrees would be my arc TH. Okay. So see how I'm doing that there? That one's pretty tough. If you have questions about that, put a star next to it and ask me. Okay. Now let's move on to segment lengths. Okay. Now this theorem is kind of ugly. I'm not going to lie. A lot of people don't like it. So I'm going to really focus on the words, and then I'm going to show you how those words apply to different situations. So for a given point and circle. So if I have a point and a circle, okay, just any point and a circle, the product means we multiply, of the lengths of the two segments from the point to the circle is constant. Okay. So I've got, again, like on the front, I have a few situations here. Situation number one is the point is inside the circle. The point referred to in the theorem is point P in this example. For the pink line, the lengths of the segments from the point to the circle, so from this point to the circle, are represented by A and B. For the blue line, from the point to the circle is represented by C and D. Okay, so hopefully you see what I'm talking about here. I'm looking at all four of those segments from the point to the line. Okay, now what the theorem says is that the product of those lengths is constant. So A times B, or AB, is equal to any line that goes through that point from basically any chord that goes through that point. I'm going to take the two sections that are made by that and multiply them together, and it's going to stay the same. So C times D. The pink line is a chord, the blue line is a chord. The two segments made by that point are constant when you multiply them together. All right. Situation number two. Scroll down so you can see, is a point outside the circle and one line is tangent. Okay, for the pink line, the lengths of the segments from the point to the circle. So P is the point, it's outside the circle. Again, we're focusing on the point. The lengths of the segments, so from the point to the circle. Well, the first one's easy, that's Y. Second one is the hard part. This is where people get messed up. The distance from the point to the other point on the circle is not Z. Z is the length of the chord. The whole distance there is Y plus Z. For the blue line, well, there's not two segments because it's a tangent line. It only touches the circle once. So we have to count T twice. So T and T, because we got to multiply it by something. All right. So the theorem stays the same. Those two segments, when I multiply them together, are equal. So what I get here is T times T, or T squared, equals Y, the first segment, times the second segment, which is Y plus Z. Situation number three is, again, a point outside the circle and no lines tangent. For the pink line, the lengths of the segments from the point to the circle are Y and Y plus Z. You should have, that's the exact same as the previous problem. For the blue line, there's no tangent line here. It's very similar to the pink line. It's W and W plus X. So the theorem says that those products are the same. So the Y times Y plus Z equals W times W plus X. Okay. You might be wondering why there's not a fourth situation where we have a point outside the circle and both lines are tangent. It's because we know from the tangent line lesson 3, that both of the tangent lines are congruent. Okay, so we don't really need to have a situation 4 because we've already gotten that taken care of. So now let's practice it. All right, so where, again, just like with angles, where is the intersection? Where's the point created by the intersection? So on this one, it's outside, right? Pretty clearly outside. And so identify the segments. So segment 1 is 6. Segment 2 is all the way across. So 6 plus 8. I could just write 14. If I'm going to use the theorem or the formula that I showed you, it's 6 times 6 plus 8. You just want to plug and chug, that's what you would do. The other one is 7 times, the whole thing here is not Y, it's 7 plus Y. And now it's just algebra from there. So 6 times 14, change color so you can see what I'm doing here. 6 times 14 equals, now I got to distribute here. I can't put 7 and y together. So 7 times 7 is 49 plus 7y. All right, so 6 times 14, 84 equals 49 plus 7y. I know I'm going right into that other picture. Subtract 49. 84 minus 49 is 35. So 35 equals 7y, and y equals 5. And you can check it. Okay. 6 times 14, is it equal to 7? And if 7 plus 5 is 12, 7 times 12 is 84. Okay, so that is the first one. Second one, this point is inside the circle. Okay. And everything's actually given to you. So I'll do the easy one here, 7 and 7. So 7 times 7 equals, well, the other chord or diameter here is 4.8 and x. So it's 4.8 times x. So you got 49 equals 4.8x. Divide by 4.8. You get 10.2 roughly. I didn't say what to round it to, so let's go 10.2. And there you go. Inside the circle is typically a little easier than outside the circle. Last one is the second example. I've got a tangent line this time. So the tangent line, there's only one segment from the point to the line, and that's z, so I got to count it twice. Z squared equals 8 is the first one. That's the easy one. The second one is 8 plus 16. So z squared equals 8 times 24. 8 times 24 is 192. Didn't say what to round it to. I'm going to go ahead and give it in simplest radical form just because it's good to practice. I know that 2 goes into that 96 times. 96 is 2 and 48. 48 is 2 and 24. A lot of 2s here. 4 and 6. 2 and 2. And 6 is 3 and 2. So I got a pair of 2s, that's a 2 on the outside, another pair of 2s, that's a 2 on the outside, and then another pair of 2s, it's another 2 on the outside, and a leftover 3. So it's 8 radical 3. If I said round to the nearest tenth, you would just type in square root of 8, 192, or 8 square root of 3, and you should have gotten 13.9. Okay, so real quick recap. Not just of the segments, but of both. First thing you want to do is, are you looking for an angle or are you looking for a side? If you're looking for an angle, you're using the front. If you're looking for the side, you're using the back. All right. Then where's the intersection? Is it inside or outside? That gives you the different situations. If you follow that basic template, you should be okay with this lesson. And that's it.